Welcome to the brand new episode of Ecos by Jigyansa. Today we have Dr. Tirtha Pratim Dash, who is the Director of Science Program at ISRO headquarters, who is responsible for programmatic orchestration of all science activities like Chandrayaan mission, Aerostat mission, and many other future missions. Let's welcome him. Welcome, sir. We are really honored to have you here, as you have been here for 2 to 3 days, I guess. So, what are your experiences of IISER Berhampur?
IISER Berhampur has been excellent, and especially I would like to mention the students who have been maintaining this enthusiasm continuously for these 2 days. Especially, it is not very easy to have organized this kind of a program on TEDx, and that too pulling out these many speakers from different parts of the country and keeping them engaged, coordinating with all the teams. So it has been a very good teamwork. I would like to congratulate all of you, the students, to have accomplished this.
Thank you, sir. So we have few questions for you. As you are an excellent science communicator, so what potential do you see of the science outreach and communication in India?
There are quite a few opportunities present because in 2024 we are equipped with lots of technologies. And these technologies will help us to reach out to a more efficient extent. Like if you're having, the audiovisual means of extending is one way, then you can also, purely audio clips you can make them reach out to the different communities. So that is another way of doing. Also, there is another way to prepare, small booklets on different types of subjects which you want to convey to the community in regional languages, which is very important. And not necessarily everything has to be in any particular language. It should not be only in English. So my suggestion would be, today technology is there with you. Why don't you take an initiative to make this information about what is happening in the country reach to people at different levels. So what you can do is, you can stratify the target into different levels. Like maybe the primary school students will understand a particular type of speaking, then secondary students, higher secondary students. So if you are having a plan of engaging them with suitable contents in English as well as in the local language, that will indeed be a very helpful activity to the community. So.
As in your talk at TEDx IISER BPR, you related your research to music. What makes it easier for people to understand science? What tips do you share to people communicating science?
One way to the outreach aspect of it is to make it understand that whatever you think as very difficult need not be that difficult. It is very easy. And if somebody wants to make it appear difficult, then there is a problem with the person, not with the subject. So that is one aspect of it. And one message which I would like to give, which I have mentioned in my talk also, that there are lots of elements which are found in the wildlife or everywhere in nature, which help you to relate with something you're studying as so-called science. Okay, so whenever we explain some physical phenomena to a kid or a student, if we can cite an example of what is happening, whether a waterfall is falling, potential energy giving rise to kinetic energy, or whether there is a windmill rotating and giving rise to electricity, all these things, if you can relate and then tell, then it becomes easy. So music is also something like this. Music goes one level below to the most fundamental. Music has its own language, so that language allows you to modulate that part of self, communicate to that level between two individuals, which is not possible through any language in the linguistic sense. So that's how music comes to picture. So maybe I will not elaborate much on this. One example could be that you can find out using today's technology. There is a physics of how the clouds are formed. So people say that there is a cloud condensation nucleus, and around the cloud condensation nucleus, things accumulate and then When water vapor gets accumulated, it becomes a water-bearing cloud, and then rain falls. So in music, there is a concept in Miyake Mallar that the way that I think it is Komal Nishad that is used continuously. I cannot sing, so I cannot demonstrate this. Continuously, if you go on applying that particular swara tone, it gives you a feeling that there is something and around which things are getting nucleated. So the musical swaras will give you that kind of a feeling, which a science teacher is teaching. There is something called cloud condensation equally, and things are getting developed. So maybe from the art sciences, you will be able to appreciate it better. So this is my take on the overall thing.
So we would like to get an overview of the current and upcoming science missions at ISRO.
Currently, as you are aware, there are a few science missions which are active. One science mission which is very much active is the AstroSat, which was flown in the year of 2015, and it is yielding very good science observation, and lots of publications are happening. So that is an astronomy mission wherein you have different instruments which is studying celestial bodies at different wavelengths. So that is something unique because every wavelength of light has got some story or the other to tell. Okay, so when you have a system which has multiple wavelengths and same object can be seen through this many wavelengths, lots of story come out. So that is AstroSat. Then we have another mission which is still operational, that is our Chandrayaan-2 orbiter. Chandrayaan-2 orbiter is operational from 2019 and it is orbiting around the moon in a polar orbit, 100 kilometers above the surface of the moon. So it is 100 kilometers circular polar orbit. So from that orbit, the orbiter is studying the moon's surface, moon's subsurface that is underground, and also the tenuous atmosphere of the moon, which we call the lunar exosphere. So already many discovery class of findings have come. One or two, if I have to name, that direct, not very unambiguous detection of the water on moon, on the surface of the moon as water, ice. That is one of the observations. Another one is the distribution of the argon-40. There is an element and how is it distributed globally on the moon. It has got something to tell about some radioactive phenomena which is happening in the underground of the moon. Similarly, there are many others, like first time sodium mapping on the moon. Sodium comes from the major sources, the bombardment of the meteors. So they deposit a lot of substances. One of them is sodium. So global mapping was not done. So we have done for the first time. So I can go on telling many. So that is one mission. In addition to that, we are also having the recently launched ones, the Aditya L1 mission and the ExpoSat mission. As you know, the Aditya L1 mission is studying the sun it is placed at an orbit which is called a halo orbit around a point which is called the first Sun-Earth Lagrangian point. Sun-Earth Lagrangian point, the first Sun-Earth Lagrangian point is the one where the gravitational fields of the sun and the earth, they cancel out, which is closer to the earth. So if the sun-earth distance is 150 million kilometers, the first Lagrangian point would be closer to the earth, around 1.5 kilometers, so 10% of the whole sun-earth distance. There the gravitational field cancels out. So if you keep something there, ideally it is supposed to be stable. It should not move here or there. But that doesn't happen. There are a lot of other perturbative forces. So what happens if you want to stabilize something? You should have an orbit around that point, which will make it, somewhat stable. You can compare it with cycling, bicycle. Bicycle is, otherwise unstable. It will fall either here or there. But when you are running the bicycle, it is stable. Halo orbit is like that. Okay, so it is the halo orbits. The unique selling point is that when you are placing some spacecraft in the halo orbit, you are outside the magnetosphere of the Earth. Okay, when you are outside the magnetosphere of the Earth, you can study the charged particles which are coming from Sun, which is not possible when you are within the magnetic field of the Earth, because charged particles get deflected by the Earth's magnetic field. Secondary advantage is, from this Lagrange point, you are never going behind the Earth. So you are never getting eclipsed by the Earth. Continuously, 24/7, you are getting the view of the Sun. These two advantages are there. And there are missions from ISA and NASA. India is the third agency. ISRO is the third agency to have put. That is one mission. Yet another mission which I would like to mention is the XPOSAT mission. XPOSAT is an X-ray astronomy mission where you are studying the polarization of the X-rays, which is also a new facet. After NASA, we are the first, that is, we are the second in the globe to have had a space-based observation which can study the polarization of the X-ray coming from the bright astronomical sources. So when you are able to study the polarization, you are able to tell a lot of things about the configuration of the magnetic field and different processes in the celestial object which you are interested to study. So this is the extra dimension. People otherwise study the, intensity of the light which is blinking, increasing and decreasing. That is one facet to study. People also study spectroscopy, like what wavelengths are coming, all these things. But polarization measurement is, you can say, is the third dimension. To tell something which you cannot tell otherwise using intensity change observation or observing the spectroscopy. So that mission is also on. And also you have been listening a lot about the Chandrayaan-3 mission. Formally the mission is over, but that mission was meant for around 10 to 12 Earth days, and you know that one Earth day is equal to around 14 moon day because of the rotation rate of the Earth with respect to the moon. So when we say one, moon day, already Earth has completed 14 days. It is that kind of an equivalence. So that mission has been over, and very recently we have got one paper published in a very prestigious journal called Nature, where we have shown with the rover, one of the instruments was there in the rover which was measuring the elemental composition of the lunar regolith at different places. So from these observations, some science has come which is telling that our belief that moon was once upon a time magma ocean. It was a sphere of magma. Okay, and that hypothesis which was there, that got validated, and not only that one, it also told that wherever we have landed, 69 degrees south, which we have named Shiv Shakti Point, there, that place is rich in magnesium, which is also a property of another region of the moon. If you take a globe of the moon and if you see the South Pole, if you go slightly towards the, far side of the moon, there is a region called South Polar Aitken Basin. There, part of the moon is scooped so that you can see a part of the mantle also. That kind of material is also available in the Shiv Shakti Point. So without going there, you are studying this. So what happened when the moon formed, the dynamics of the initial moon, all these things you can study from these kinds of observations. So these are the missions currently we are very much speaking about in ISRO.
Okay. So as you mentioned, we should spread science through outreach and every of that. So like in IISER Berhampur, we have a science outreach club, that is Jigyansa, where we share our perspectives and all the viewpoints it's bilingual in our Odia languages, in Odia language and other languages. So what are the more points you can give us to enhance
these activities? What you can do is in ISRO headquarters, there is an office called Capacity Building Program Office. Capacity Building and Public Relations Office it's called. So we call it CBPO. So CBPO is the office that deals with these kinds of outreach program. And CBPO also, just for your information, they are the people who are authorized to be the public relation officer of ISRO. Okay. So coming to your outreach, it will be of great opportunity if you can formally write to ISRO and seek their guidance. I believe that the management of ISRO will connect you with the CBPO office. CBPO office will help you to reach out in a much more bigger extent, and we may come into picture as far as the domain knowledge is concerned. So we are very much familiar in speaking physics or speaking technology, all this. But how to make an outreach effective in ISRO, that component is CBPO. So my suggestion would be in touch with them.
Thank you. So my last question would be, share any of your memorable experience or achievement from your work at ISRO that you are particularly proud of.
There are in fact many. The first one, the Moon Impact Probe where I have worked. This Moon Impact Probe was released from the Chandrayaan-1 orbiter on 14th of November 2008. And during that time, it was my first planetary science mission. And previous to that, I was working in the domain of launch vehicles. So basically, I joined ISRO as a rocket technologist. So I worked on PSLV, GSLV, especially on the liquid stages of PSLV, GSLV. And 2006, I got a transition from rocket to planetary science. And then Chandrayaan-1 mission was flown, and then Moon Impact Probe was the first impactor to have been impacted on the moon from Asia. So I got an opportunity to work there, and that instrument worked very well, and it had one instrument which is called CHASE. CHASE instrument is basically a mass spectrometer, and where I worked. So this instrument used to study the composition of different gas molecules and atoms in the environment of the moon. So we know that moon doesn't have any atmosphere, but there is a very thin environment. That was measured for the first time in the sunlit condition, because it really matters in moon whether sun is there in sky or not. It is not like Earth. On Earth, as environmental science student, earth science student, you know that nitrogen remains to be the dominant constituent whether it is day or night. Atmospheric pressure will not change drastically. It will remain around 1000 millibar day or night. Moon doesn't behave like that. Moon day and night pressure differences by a factor of 100. Day side pressure is high. High means that too very low. Night side very, very low. Factor of 100 difference. The dominant gases are also keeping on changing. Okay. So what happens in the day side was not known. It was studied for the first time by us. And also for the first time, we only have announced or told about the water vapor in the moon's atmosphere or moon's exosphere, to say in a better way. So although after that, I am very fortunate to have gotten an opportunity to work in many missions. Even after Chandrayaan-1, all the space science missions I have worked in some capacity or the other. But something which you did fast and which was having impactful, which gave you lots of opportunities to learn, especially somebody is changing domain from rockets to planetary science, that experience still remains within you. So since you asked this question, first answer came to me was this. This enthusiasm is good, and first I would like to appreciate that IISER Bhopal has got an outreach wing, and you always feel the need, or your management does feel the need, not only to impart education to you, but also creating this urge to spread out. At this juncture, I would like to mention about one shloka which is there in one of our ancient texts, which says that Atmana Makshartha Jagadhitaya cha. Atmana Makshartha means for yourself you are doing. You are studying, you are having different exams, you are undergoing lectures. But Parahitaya cha, what you are doing, you are going outside through this wing of outreach team, and you are making people aware, talking to people, getting to know what people understand. You are not sitting in the ivory tower where you lose connection with the people. That is not happening. So for this, I congratulate you and your management also, and wish you all the best.